Okay. Abraham, can you mute yourself? Okay, good, good, good. So we can now start. So last week we started with calculus. We talked about differentiation and integration, which we talked about limits and the rest. Now today we'll be delving much more deeper into differentiation and its rules. But let's take a quick look at limits, then we can continue. Okay, so last week we were talking about limits. We talked about calculus being the study of differentiation and integration, the limit of a function, which is the foundation stone of differential calculus. We talked about the limit of a function x, where x is approaching a, and represented that with L, where L are real numbers. Therefore, the limit of the function x with x approaching 1 will be equal to 1 because you represent the x with 1. We talked about rules for limits. Rules for limits. We talked about the constant rule, where the limit of a constant is the constant itself. So it is, for example, lim of 9, where x is approaching 1 is equal to 9. We talked about the power rule, where the limit of a function with a power. Welcome, Kelvin. We talked about the power rule, where the limit with a power, where x is approaching a certain number, will be that number which x is approaching will be the power. Therefore, the limit of x raised to the power 2, where x is approaching 3, will be 3 raised to the power 2, and that will be equal to 9. We also talked about the product rule, where the limit of a function, which is b multiplied by a constant. Good, Kelvin, good. Okay, so the limit of a function, that's f of x, which is being multiplied by a constant, which is k, that's with x approaching a certain figure, will be, you move the constant to the back of the limit before you solve the equation, and you are going to get 54 with this one. We talked about the sum and differences rule, which is the limit of a function, which is we have an addition or subtraction of another function. We talked about separating these two functions before you solve. So for example, the limit of 3x cubed minus 2x squared, where x is approaching 2, you get the limit of 3x cubed where x is approaching 2 and the limit of 2x squared where x is approaching 2 before you solve for your answer. We talked about the product rule when one function is multiplying another function in a limit function. So in this instance, for example, lim of x plus 3 multiplying x minus 2, x approaching 4. You have to separate them first before you solve. So you have the limit of x plus 3, x approaching 4, then the limit of x minus 2, where x is approaching 4. Before you insert your 4, or you substitute your 4, 4 plus 3 times 4 minus 2, that will give you 7 times 2, that is equal to 14. We also talked about the quotient rule. The product rule is when they are multiplying. The quotient rule is when they are dividing. The limit of one function is dividing the limit of another function. In this instance, you again separate the two functions before you solve. Then we talked about the exponential rule, which is the limit of one function having an exponent. So this function is having an exponent where n is greater than 0. Then we moved on to derivatives, which is differential calculus, where we talked about the change. So the mathematical way of finding a change of one variable to a change in another variable is what we term as differentiation. So normally in demand and supply, you'll be looking for a change in one commodity to the change of price in another commodity. That function that you'll be solving in economics is the same as differentiation here. But in economics, sometimes you'll not be applying the rules of differentiation, but most of the time you apply the rules of differentiation. That's in higher level differentiation. Now we talked about when you are given the function y, which is equal to f of x, the derivatives of that function f at x will be written as f prime of x or y prime or dy dx. So any of them, if you have a function in, you are asked to differentiate, you can differentiate the function f of x in respect of f prime of x, which you'll be getting this function. That's the limit of f of x plus the change of x minus the function f of x all over the change of x, where the change of x is approaching 0. Okay, so last week we talked about this one. Then we also talked about the rules of differentiation. We talked about only 3 rules of differentiation, which is how we normally solve differentiation questions. We talked about the constant rule, we talked about the linear function, then we talked about the power rule. The constant rule, which is to differentiate a function, you will get 0. Because if you are differentiating in respect to one variable. So if you are to find the change in 2 variables, that is change in quantity demanded over change in price. And all you are doing is to find the change in price. You don't have the change in quantity demanded. That is going to give you 0, or that is going to give you an undefined function, whichever way you'll be solving it. Therefore, the function f of x is equal to k, which is a constant. If we differentiate it, we'll be getting 0 because there is no x attached to it for it to be differentiated. So the constant rule states that if you differentiate any constant, you'll be getting 0, and that's it. And the linear function, that's when you have f of x is equal to mx plus b. In this instance, you have x there. Therefore, you can differentiate it. Since this is not a constant, but it's a function, you can differentiate it. Now, as we said earlier, b is a constant and b cannot be differentiated. Or when you differentiate b, you get 0. So that's 0 there. Now, in this instance, differentiating m of x, x has an invincible power of 1. Therefore, if you are differentiating this 1, that's the m of x, you will be multiplying that invincible 1 by any figure in front of the function. And in this instance, it is 1. In this instance, it is 1. So 1, which is the exponent, by 1, which is in front of the function. Is that okay? The function x. After that, you subtract 1 from the exponent. That's why you'll be getting mx raised to the power 0, which with 1 in front here, which is invincible. Then we get an m. Then we talked about the power rule when there is a power. Now, in this instance, there was no power. It was a linear function, but there was an invincible power 1. That's why we call it a linear function. Now, when there is a power, maybe 3, 4, 5, or 6, you'll be getting kx raised to the power n, which is the original function. Now, you multiply this n by any invincible number or any number in front here. And in this instance, it is 1. Is that okay? So you multiply the n, the power, by the 1 in front here, and that will be n by 1. After that, you subtract 1 from the power. That's n minus 1. It's the same thing that we did here. Is that okay? Okay, so before we move on, I think I gave you an assignment, right? Right? Hello? I'm unmuting all of you. Okay, can you unmute yourselves? Yes, Sparky. I think I gave you guys assignments, right? Abraham.
Sir.
I think I gave you guys assignments, right?
Last time I wasn't there.
It wasn't there.
I was in class.
Oh, okay. Sparky,
Say.
I think I gave you guys an assignment, right? The rest are not unmuting themselves. I've seen you, Teresa, Kelvin, Jerry. I think I gave you guys an assignment last week.
Sir.
Yeah. Teresa.
Sir, I wasn't around though.
Oh, okay. I see. Basira, were you around last week? Welcome. Okay. Okay, so one question for you, then we can continue. One question for you. Differentiate 3x squared. Differentiate 3x squared. I want the answer in the group chats. Differentiate 3x squared. Okay. So we will continue with the rules of differentiation here, and we will be talking about the differentiation of a sum or a difference. When you are differentiating a sum or a difference. Okay, differentiating a sum or a difference. Now, to differentiate a sum or a difference, this is how the function will look like. That is, you have the function dx with this function f of x plus g of x minus h of x. Is that okay? So what you need to do is, we don't have y in front there because this is not equated to y. Is that okay? That's why we are having only the d over dx because we don't have the y. Is that okay? So because we have only x, the difference of any variable that will come up here over the difference of x, that is d dx. So that will give us the function f of x, g of x minus h of x. We are combining the sum and difference. So as we did for the limits, is that okay? As we did for the limits, this for differentiation too, we are going to do the same thing. You are going to separate all the functions and differentiate them one after the other. So in this instance, let me use the annotation. So in this instance, f of x will be separated here, which is d dx f of x. G of x will also be separated, d dx g of x. Then h of x will also be separated, d dx h of x. I hope you get it. So that's how you solve it. You don't solve everything together. You separate all the functions, then you solve it as it is. Now let's go to the example. The example now is equated towards y, which is y is equal to x raised to the power 4 plus 1 over x minus 6x. Is that okay? Plus 1 over x minus 6x. Let me put the 1 over x in brackets not to confuse us. Okay, so x raised to the power 4 plus 1 over x minus 6x. Now, if you get a question in this form, which is a question having a denominator of x, what you need to do is to bring the x up. Is that okay? You bring the x up, and when you bring the x up, you'll be getting x raised to the power negative 1. Is that okay? You'll be getting x raised to the power negative 1. If you bring your normal indices, the normal indices, if you have 1 over a certain number and you want to bring that power up, you'll be getting what? A negative 1. So it's the normal indices we are using here, not anything unhudious. So this is it. The 1 over x, you bring the x up so that you'll be getting x raised to the power negative 1. If it was supposed to be 2 over x, then it would have been 2x raised to the power negative 1. Is that okay? 3 over x will be 3x raised to the power negative 1. So that's how it is done. Okay. Now, you separate all the functions. It's because of the 1 over x, that's why I'm talking so much about that one. But you separate all the functions. That's d dx of x raised to the power 4 plus d dx of x raised to the power negative 1 minus d dx of 6 raised to the power 6x. Is that okay? Now what you need to do is to now differentiate it in respect of what? Y. You differentiate y in respect of x. That's, you differentiate the function y in respect of the function x. That's what we are doing here. Therefore, to differentiate x raised to the power 4, you multiply the 4 by any number in front of the x. And in this instance, it is an invincible one. So please, the person drawing on the screen, check it. Clear the drawing for me. Okay. So you multiply the 4 by this invincible one. Is that okay? That will give us 4. Then the x will come. After that, you subtract 1 from the 4, and that will give us what? Cube. So x raised to the power 4 differentiated will give us what? 4x cubed minus this one. So you multiply the negative 1 by any number in front here. That will give us what? Negative 1. Then x raised to the power, this is negative 1, and you must subtract 1 from it. Negative 1 minus 1 will give us what? Negative 2. Is that okay? After differentiating, you bring it to its natural form, which is this 1 over x. So you bring it to its natural form, it will give you 1 over x squared. Is that okay? Because the negative 2 will be up here. When it comes down, to be x squared. This is the normal indices that you know already. Okay. After differentiating, therefore you'll be getting 4x squared, 4x cubed minus 1 over x squared. As you know, the squared is coming from subtracting negative 1 from negative 1, and that will give you negative 2. But when it is a numerator, it is negative. When it becomes a denominator, it becomes what? Positive. So that will be 1 over x raised to the power 2. Then minus 6. Differentiating 6x, you have 1 exponent 1. You multiply it by the 6, you get 6. X raised to the power 1 minus 1 will give you 0. Any variable raised to the power 0 is 1. Therefore, it will be 6 times 1, and that is 6. Therefore, using the sum or difference rule, okay, so the 4x raised to the power 3, it is x, we are differentiating x raised to the power 4. Is that okay? X raised to the power 4. Therefore, you multiply any number in front of the x by the 4, and that will give you 4. Then the x, 4 minus 1, that's the rule for differentiation. When you multiply the exponent by any number in front, you subtract 1 from the exponent. So 4x, then 4 minus 1, that will give you 3. That will give you 4x cubed. I hope you get it. So this is how we use the sum or difference rule. You must always put it in mind that you have to separate all the functions before you continue solving. Okay, good. Now the next rule. The next rule is the product rule. The next rule is the product rule. Product rule is when the functions are multiplying themselves. So if y is equal to u times v, that's uv, where u and v are both functions of x, then let's take it as, then we'll be getting dy dx will be equal to, you pick the v, then you multiply it by the difference, what you are differentiated. Let me pick something and explain it here. So you have y, is equal to u times v. Is that okay? So what you need to do here is that you will differentiate u in respect to x, because u will be a function. So let's take that u is a function, which is 3x plus 1. And v is also a function, which is equal to 2. Yeah, let's say 2x minus 1. Is that okay? So what you need to do, which is the product rule, as you can see, these two functions will be multiplying. So what you need to do is that you pick the last one, which is the v. Then you multiply it by the differentiation, the first derivative that you will get. You multiply it by the v. So that's why you'll be getting the u over what? The x. Then plus, you pick the u. Then you multiply with the first derivative of the function v. Is that okay? And that will give you the v over the x. I hope that's cool. So that's how it is. You pick the first one, that's v. Then multiply by du dx. Then you pick u, multiply by the v dx. Let's take this question and solve this example for you to understand it better. So we have y is equal to 3x squared plus 1, 5x minus 8. As you can see, these two functions are multiplying. So we need to use the product rule here. So using the product rule, we will let u be equal to 3x squared plus 1, which is one function. And v2 will be equal to 5x minus 8, which is another function. So now what do we need to do? We need to differentiate these two functions so that we can multiply each other. I did this straightforward, but let's differentiate it, then we can continue. So you have u is what? 3x squared plus 1. If we differentiate u with respect to x, that's du dx. So we are differentiating the function u with respect to s, that's du dx. It will be equal to, you multiply the 2 by any number in front of the x, and this time it is 3. So that will give you 6x. Then 2 minus 1 will give you what? Raised to the power 1, which is invincible. We don't write it there. So differentiating 3x squared will give you what? 6x. Plus 1 is a constant. Differentiating a constant will give you 0. So differentiating u, which is 3x squared plus 1, will give you 6x. Now after that, you pick the v, which is what? 5x minus 8. We are differentiating v in respect to x. That's the v dx. And that will be equal to what? There's an invincible one, which is x exponent 1, which is invincible. You multiply it by the 5 and you get 5. Then you get x raised to the power 1. You subtract 1, the rule for differentiation. When you subtract, you get 0. Any variable raised to the power 0 is what? 1. Therefore, it will be 5 times 1 minus the constant, which is 8. Therefore, the v, the x will be equal to 5. So as we have differentiated, we will go back to our formula, which says that when you have a product rule, you pick the second function, which is v, which you have represented with v. They multiply it with the first differential of the u. So you pick the v, which is 5x minus 8. This is it, 5x minus 8. This is it, 5x minus 8. And you multiply it with the first differential of what? The u, which is what? 6x. As we are solving here, 6x. Then plus, you pick the u, which is what? 3x squared plus 1. You multiply it with the first differential of the v, which is 5. So that's it. After that, you use your normal algebraic expression to solve it. So 5x by 6, that will give you 30x squared. 8 by 6x will give you 48x. You have your negative there. 5 by 3 will give you 15x squared. 5 by 1 will give you 5. And that will land you with the answer. 45x squared minus 48 plus 5. Any question? Any question? Okay, so since there is no question, we'll continue to the next one. Which is the quotient rule? The quotient rule. Before we go to the quotient rule, let me give you one question, then you solve. Sorry, I wasn't recording. So you have what v du dx minus u dv dx all over v squared. That's the denominator squared. So for this question, you have y is equal to 2x plus 3 all over x minus 5. Therefore, you let u be equal to what? 2x plus 3. And v be equal to x minus 5. So when you differentiate this, you'll be getting du dx will be equal to what? 2. And dv dx will be equal to 1. Because when you differentiate x, you'll be getting 1. 1 multiplied by 1, then 1 minus 1. This one gives you 0. Then you get 1. So x minus 5, if you differentiate, you'll be getting 1. After that, you pick the v. That's x minus 5. You multiply it with the first differential. That's the u dx. Minus, you pick the u. That's what? 2x plus 3. You multiply it by the dv dx, which is 1. After that, all over x minus 5 squared. Is that okay? After this, everything is algebraic expression. After this, everything is algebraic expression. The answer for the algebraic expression is too long. That's why I didn't include it. But you can solve it yourself and get the answer. Is that okay? So that's how you do it for the quotient rule. So you have to always remember that for the product rule, you have v du dx plus u dv dx. But with the quotient rule, it's the same v du dx minus u dv dx all over the denominator squared, which is v squared. That's for the quotient rule of differentiation. Let's move on to the next one very fast, which is differentiation of function of a function. That's using the chain rule. So we'll talk about high derivatives, then we are done. Okay. So differentiation of a function of a function. Now, this is the side that if y is a function, let me use this thing to explain. If y is a function, this is a function of y. Is that okay? If y is a function of u, and u is a function of x. So if y is a function of u, this whole thing is, we are using it as what? We are simplifying it or denoting it by u. If y is a function of u, so y is equal to u, and that u is equal to x minus 3, x squared plus 7, 7x minus 1. Okay. So if y is a function of u, and u is a function of x, as you can see, u is also a function of what? X, which is there are functions of x inside this function u. Then y is called a function, this whole function of a function. This one's inside here. Is that okay? Y is called a function of x. That's what we term as function of a function. Now let's pick this question and know how to solve this question. Now with this, you first have to simplify it first. Then after that, you solve it using the old differentiation method now. So you simplify it, which is x by x squared will give you x cubed. X by 7x will give you 7x squared. Negative 3, then x by negative 1 will give you negative x. Negative 3 by x squared will give you negative 3x squared. Negative 3 by 7x will give you negative 21x. Then negative 3 by negative 1 will give you positive 3. After that, you'll be getting, you simplify it, and you'll be getting x cubed, which is this one, plus 4x squared, which is 7x minus 3x squared, minus 22x, which is minus 21x minus x. This is negative, negative, therefore you get a minus 22x. Then you have only one constant, which is what? 3 plus 3. I hope you get it. So you simplify it to this form. Then after that, it will become easier for you to what? To differentiate. Therefore, when you differentiate this, now differentiation, you don't have to be writing, when you multiply 3 by the number in front, you'll be getting this minus 1, getting that. No. We differentiate with our eyes. Is that okay? So you look at it, then fast, you differentiate. So you look at this. This is x raised to the power 3. This 3 will multiply x minus 1. You'll be getting what? 3x squared. So x cubed is what? 3x squared. 4x squared. Multiply 2 by 4, you get 8. You subtract 1, you get what? 1. That'll give you what? 8x. When you simplify this one, x, this one by this one, you get 22 minus 22 minus 1. That'll give you 0. That'll give you 22. So when you are in the exams room and there's a differentiation question, you don't have to now write it down and 3 times 1 x, then 3 raised to the power 3 minus 1 before you get your 3x squared. Do the calculation mostly in your head. So practice as you do it. When you see any function like this one, 7x squared, then you try and differentiate it. That's what? 14x. 7x squared is what? 14x. Is that okay? 3x squared, that's what? 6x. 21x will give you what? 21. X cubed is what? 3x squared. So practice with it and you'll be more efficient with differentiating figures as it, okay? So this one, you get 3x squared plus 8s minus 22. Differentiating a constant is 0. So that will give you 0. That's it. That's all about differentiation of function of a function. That is the chain rule, okay? The chain rule. Now, after that, we have this, which is the higher derivatives. The higher derivatives. Now, when you differentiate it once, that's the first derivative. Is that okay? So differentiating a function once is the first derivative. Differentiating a function once is the first derivative. When you differentiate it again, that it becomes twice. That becomes what? The second derivative. It becomes the second derivative. So if y is a function of x and it is differentiated, it results in what? Dy dx. Now, if this dy dx is differentiated again, it will be called the second derivative of y, and it is denoted by the 2y over the x squared. That's how it is pronounced. Is that okay? The 2y over the x squared. Most people will say the squared y over the x squared. No. It is the 2y over the x squared. That's how it is pronounced. That. So you'll be having the 2y over the x squared. So let's pick an example. You have y is equal to 3x raised to the power 4 plus 2x raised to the power 3 plus 2 over x squared. Now, remember indices here. 2 over x squared. So differentiating this one once will give you 12x cubed, which is 4 by 3 is 12. 4 minus 1 is 3. So 12x cubed plus 6x squared. 3 by 2 is 6. 3 minus 1 is 2. That's 6x squared. Then this one, 2x squared. What do you need to do? You need to bring the x squared up. You need to bring the x squared up. So you have 2 over x squared. So you have to bring the x squared up so that you'll be getting 2 into bracket x raised to the power negative 2. Okay, that's what you'll be getting. Now when you get this, you differentiate it. That's, sorry. So what do you need to do? You need to do what? You need to differentiate this. So negative 2 by the 2 in front here will give you what? Negative 4. That will give you what? Negative 4. Then the x, when you subtract 1 from negative 2, you'll be getting what? Negative 3. That's why we have what? Negative 4 over x cubed. When you change it to the normal function, you'll be getting negative 4 over x raised to the power 3. Normal indices, okay? Normal indices. After differentiating, you apply normal indices to move it back. That's why we have minus 4 over x raised to the power 3. So as you can see, we have differentiated this. As you can see, we have differentiated this function. We have differentiated this function. Is that okay? We have differentiated it, and this is it. Now, normally that's it, but we are being told to differentiate it again. That is, after differentiating the normal function, you will get the first derivative. That's 12x cubed plus 6x squared minus 4 over x cubed. When you are asked to find the second derivative, you'll be getting what? You'll be differentiating it again. You'll be using the normal principles in differentiation. When you use the normal principles in differentiation, you'll be getting this. That's 3 times 12. That will give you 36. 3 minus 1 will give you 2. That will give you 36x squared. Plus 6 times 2 will give you what? 12. 2 minus 1 will give you what? S. Sorry, 1 second. That will give you x. Is that okay? Because 2 by 6 will give you 12. 2 minus 1 will give you 1. X exponent 1 is the same as x. Then plus, you change this one again. You make it 4 into bracket. X raised to the power negative 3. Now, negative 3 by negative 4. Let me do it for you to see. So you have negative 4 over x raised to the power what? 3. Now you move it up, you'll be getting negative 4 into bracket x raised to the power negative 3. Now you multiply this negative 3 by the negative 4 there, and you'll be getting what? Positive 12. Then x raised to the power negative 3 minus 1 will give you what? Negative 4. That will give you negative 4. So you'll be getting 12x raised to the power negative 4. Now you use normal indices to convert it back to the normal state, and you'll be getting what? 12 all over x raised to the power 4. So that's why we have what? 12 over x raised to the power 4. So that's differentiating it again. That's the second derivative or higher derivative. Let's use this one here. Okay, so we differentiated it once. That's s cubed plus 4s squared minus 22s plus 3. We differentiated it once and we got what? 3s squared plus 8x minus 22. If you are supposed to differentiate it again, that's the 2y over the x squared. I will not write it so that it will be maya here. So the 2y over the x squared, if you are supposed to differentiate it again, you'll be getting what? 6x plus 8. Okay, you'll be getting 6x plus 8. If they tell you to find a third derivative, which is not common at the senior high school level, exactly, they tell you to find a third derivative. It is not very common, but you can be asked to find a third derivative. That's the 3y over the x cubed. Exactly. The fourth one, the 4y over the x. I've even forgotten it. Let's continue. Okay, so in this one, if you have asked to find the third derivative, you get 6. That's it. Then you continue. Okay, fourth derivative, you'll be getting 0. That's about differentiating in the higher levels. That's the higher derivative, the second derivative, the third derivative, the fourth derivative, etc., etc. Now, the last thing that we need to talk about is differentiation of implicit functions. Differentiation of implicit functions. But before we do that, I would like you to do this one for what we resume. Okay. Now the last one for today will be differentiation of implicit functions. Differentiation of implicit functions. Now when we say an implicit function, it is a function in which two variables cannot be easily expressed in terms of the other. So we cannot easily express one variable in terms of the other. So an example is x raised to the power 3 plus y raised to the power 3 is equal to 3xy. So as you can see in the previous ones, you will see that you have y is equal to, so y is at one side, then x is at one side of the equation. So in this instance, you can do what? Easily differentiate. But in this instance, it's combined. There's x cubed, there's y cubed at one side, then there's 3xy at another side. So as you can see, you cannot easily differentiate this one. How are you going to differentiate it? You don't have a very specific function for x. Exactly, you don't have a very specific function for x where you differentiate in this way. Therefore, to solve an implicit function, you have to differentiate it 10 by 10 to give an equation that will include x, y, and dy dx. We'll solve a question and you understand it better. Exactly, you have to differentiate it 10 by 10. Then after you make dy dx the subject of the equation, and you solve. So an example is this. You have x squared minus 3xy plus 2y squared minus 2x is equal to 4. To find the value of dy dx at the point, well, at the point 1, -1. I hope you know this point. X is 1, y is -1. I hope you know it. Okay. So this is how you solve it. So for this one, you solve it, you differentiate it individually. Is that okay? Differentiate it individually. But before you differentiate it, you will check and you will see that you have a product here. That's x and y. So you have to separate it and use the product rule to differentiate it. Is that okay? You can use the product rule to differentiate, or you can separate it. Any of them goes. Is that okay? So you'll be having x squared minus 3x, that's 1. Then into bracket 3y, that's another 1. Plus 2y squared minus 2x is equal to 4. Then you differentiate each function. Okay, you differentiate its function. X squared, you'll be getting 2x. Now you are differentiating this one in respect of y. So you'll be using the product rule here, and you'll be getting 3y minus 3x dy dx. Is that okay? 3y minus 3x dy dx. Let's do it and see. I'm not seeing your faces, but I can see that you are confused. Okay, so you have 3x and 3y. This is you, this is V. So product rule, you pick the first one, then differentiate it in respect of the other, and you go on. So you'll be getting what? V, that's 3y. Then differentiate this one, you get what? 3. Then you pick this one, which is what? 3x. Differentiate this one, which will be what? dy, 3y, dy dx. Is that okay? So this is how we came by the function 3y minus 3x. This one 3y then minus 3x, then dy dx. Is that okay? Plus you differentiate this one, you get what? 4y. Since it is y and it is not x, you'll be getting what? Dy dx. Then minus 2x, which when you differentiate, you get 2. When you differentiate a constant, you'll be getting 0. So this is it when you differentiate. Now after differentiation, the rest is algebraic expression. Is that okay? You put like terms together. So as you can see, we have some like terms, which is 2x. No, let's choose this like terms. We have negative 3x dy dx. Then we have positive 4y dy dx. As you can see, we have dy dx, dy dx. So they are like terms. So we group them at one side of the equation, which is this. Then you group all the others, which is 2x minus 3y, then minus 2 at another side of the equation, which will give you plus 3y, which is negative 3 here. it comes here, it becomes positive. Positive 2x here, when it comes here, it becomes negative 2x. Then negative 2 when it comes here to become positive 2. Is that okay? You group that one too at one end of the equation. You sort it out, you'll be getting negative 3x. That's you factorize. You get negative 3x plus 4y. This one. 3x plus this one. 4y. This is it. Then you have the similar variables here, which is dy dx. You put that one two together. Now after that, what do you need to do to get only dy dx at one end of the equation? You do what? You divide each side by this variable here, or this expression here. Is that okay? So when you divide each side by this expression, this place, the expression will leave. Then it will be 3y minus 2x plus 2 all over this expression, which is negative 3x plus 4y. Therefore, dy dx is equal to this. That's how you solve an implicit function. Is that okay? That's how you solve an implicit function. First, you have to expand it. After expanding it, you do what? You differentiate. When you differentiate, you must make sure that any variable that is having what? Y. Any variable that is having y, or any figure that is having y, because it is not x that we are differentiating, you'll be getting dy dx at the end of that. At the end of that, you group like terms. After that, you factorize. After factorizing, you divide each side by the expression there. Then you get your dy dx standing at one end of the equation. Then all other variables standing at another end of the equation. Now the question said that you should find the value of dy dx at the point 1, negative 1. So as you can see, this point, the first one is the x value, the second one is the y value. So you substitute this into the equation here, which is 3y minus 2x plus y all over minus 3x plus 4y. Now when you substitute this one into this equation, you'll be getting a value, and that value will be the answer. So I intentionally left that one out for you as an assignment. Is that okay? I intentionally left that one out for you as an assignment. So you substitute this one into this equation. Then using normal algebraic expression, you do what? You solve for the value there. Is that okay? Any question? Any question? Any question? Hello? Okay, so Basia has already solved, but I still have an assignment for you. Last week I gave an assignment and you decided not to do it. This week I may bring some. So it is up to you whether you decide to do it or not. Okay. Okay, so it has been nice having you. Any question? Any question? Any question? Any question?
Hello.
Okay. So I can end the meeting now, right?